Hi, welcome to the mathcenter.com. In this video, we are going to look at an example that I found in the Specimen Paper, Paper 2, Pure Maths 9709/02, the Cambridge exams, the CIE exams, Pure Maths 2. Before we look at the question, please share this video as much as you can. Give me a like and follow me on Facebook and YouTube. If you can visit me and the stuff we provide on the mathcenter.com for all the online courses that we provide. We have lots and lots of details available on our website, the mathcenter.com. Okay, so let's start with this question here. Part 1, we have to show that tangent squared x plus cos squared x is something. Yeah. So as you can tell, identities, when you want to deal with identities, you need to know the formulas, okay, so that you can sail through them quite smoothly. So let me start. My left hand side is tangent squared x plus cos squared x. And you know the tangent squared x will be secant squared x minus 1. Okay. Let me write this as half of 2 cos squared x. Okay. So now I have secant squared x minus 1 plus half of, remember cos 2x is 2 cos squared x minus 1. Let me write it here. Okay. Cos 2x is 2 cos squared x minus 1. Therefore 2 cos squared x will be 1 plus cos 2x. So now this one becomes secant squared x minus 1 plus half cos x, and you are done with the answer. So you'll get secant squared x plus half cos 2x minus a half, and we are done. So maybe you should write equals to your right hand side. So basically identities, as I mentioned earlier, it's very dependent on knowing your formulas really well. Okay, enough about this. Let's run through the rest of the question. They ask you to evaluate an integral, except that they want you to give exact values. So we won't evaluate the whole thing. Let's just talk about the method. Yeah, we asked to integrate from 0 to pi over 4 tangent squared x plus cos squared x. So as you can tell, right, when you are given the first part, you obviously have to use the that part to go ahead and solve this problem. So 0 to pi over 4, what is tangent squared plus cos squared? We have secant squared x plus half cos 2x minus half dx. Did I copy everything correctly? Secant squared x plus half cos 2x minus a half. Okay, this is easily integrated. So let's do the integration, and then I'll let you finish the problem. Secant squared x, when you integrate, you will get tangent x. And then I have half cos 2x, so I'll get 1 over 4 sine 2x minus a half x. Then you plug in your limits. Okay, plug in your limits, and you will get your answers. Yeah, I wrote the answer down here, 5 over 4 minus pi over 8. We can check it really quickly. Let's plug in pi over 4. So I have tangent of pi over 4 will be 1. And then if I plug in pi over 4 here, it will be pi over 2. Sine of pi over 2 is 1. So I'll get 1 over 4. And then I'll have minus pi over 8. When I plug in pi over 4 here, the good news is there's a 0 in the lower limit. So forget about it. Okay, because tangent 0, sine 0, and all that's gone. And we are left with 5 over 4 minus pi over 8. Done. Finish. Yeah. So that's pretty easy as well. I want to say a few things about the last part. In the last part of the question, this is a heavy weight problem because I think there was 11 points, I think, if I remember correctly. I will post my solution together with the video as a link, so you can easily access my solution as well. Okay, you are given this curve and the equation of the curve. Please be careful, right, when you do this. on the exam is tangent x plus cos x, yeah? Y equals to tangent x plus cos x. And they ask you to rotate this region that they have shaded. Okay, you can read the question on your own, yeah? They ask you to rotate this region that is shaded 2 pi radians above the x-axis, and they ask you to find the volume, except that you have to give your exact volume, yeah? So you don't have to worry about it. I wrote the answer down here. You don't have to worry about a calculator and so on. So the answer is here, which I worked out. So basically, I want to talk about the ideas. Yeah, just be a bit careful you do this. We are looking at rotation about the x-axis. So volume will be pi y squared dx. Okay, that's a formula we learned some time ago. Yeah, pi y squared dx. So don't forget there's a pi. And what is y squared here? It will be tangent x plus cos x squared dx. Limits going from 0 to pi over 4. Okay. So I have copied everything correctly. Tangent x plus cos x. Yep, that's good. Yeah. So now we have got pi here. Please be careful. 0 to pi over 4. I need to expand this. So I'll get tangent squared x plus cos squared x. Looks good so far. And then I have plus 2 tangent x cos x. Be careful about this term. You know, I said that quite a few times already because that's where they're hoping to catch you. It's tangent squared x plus cos squared x plus 2 tangent x cos x. I haven't done any integration yet. So I have pi 0 to pi over 4. I have tangent squared x plus cos squared x. What is 2 tangent x cos x? This will be 2 sin x over cos x times cos x. So this will be plus 2 sin x dx. So, okay, let me just quickly take 2 sin x over cos x. Great, yeah. So now it's easy. Now it's easy because this part you already have the answer. Yeah, this part you already have the answer, which is what? 5 over 4 minus pi over 8. The only thing that you need to do is just integrate this 2 sin x. That's easy. When you integrate 2 sin x, you get what? Minus 2 cos x. Okay. Maybe I should write it down. I have pi. Okay. Let's write down what did we get for the, I can't remember the answer, but never mind. Okay. I'll tell you what to do. Okay. The earlier part, we worked this whole thing out. So I have pi 5 over 4 minus pi over 8. Okay. That's the first part. And then I have a 2 pi 0 to pi over 4 sin x dx. Okay. Can you see there's a pi here, there's a 2 here. So I've taken out the 2 pi and then I have a sin x and a dx. This one you can easily integrate. It's just minus cos x. Plug in the numbers and you'll get the answers. Okay. That's it. So the only thing I wanted to warn you about in this part was be careful about when you expand it. Whoever said it thought about it and they came up with this question. Very good question. Okay, thank you very much for watching. Please give this video a like and share as much as you can. Follow me on Facebook and YouTube. And thank you very much. Good luck on your exam tomorrow.